Okay, yeah. Hi, I'm Finn. I'm in Anna Kreschuk's lab at EMBL Heidelberg. I'm a software developer. I did my PhD in this group here too. And yeah, I've been working with the AI4Life consortium for a while now. We've built a lot of cool stuff, and I'm going to show you some of it today that, yeah, the parts I mainly contributed. Yeah, so let's go forward here. Yeah, what are the requirements for our fair model zoo that we create, right? We need to share the specification that to describe these metadata for all the models that we share, for models, notebooks, and data sets that we reference. And for these resources to be discoverable on the website, and programmatically understandable by our tools, we need this specification. And yeah, furthermore, we want to provide some common tools because we have a lot of tools in the community, and many of which are based on either Python or Java. So we want to provide some common tools to not, yeah, to lower the developer burden in using our models and creating tools in this domain. And finally, we need something to orchestrate at least parts of the review and maintenance process that goes along with collecting all these resources in one place. So a small selection, of course, the whole Bioimaging.io effort is grounded in the community. You also find us on ImageSC, the forum for all sorts of bioimage related questions, and on GitHub. Yeah, and then I'd say that all these community partners that make up Bioimaging.io, they benefit from this shared specification that we define in the Bioimaging.io spec Python library that I'll briefly talk about in a minute, as well as Bioimaging.io core as a common tool for the Python world. There's also the JDLL, the Java Deep Learning Library for the Java world. And then, of course, we'll have some orchestration behind our website, bioimage.io, that I'll briefly mention today too. Yeah, so the specification, what I mean, maybe sounds a bit abstract, but at the end of the day, we have a YAML file behind each of these resources that we've shared, that are shared on the model zoo, that holds crucial information. And yeah, so it's somewhat straightforward, a YAML file with a very defined pattern, and you can use the Bioimaging.io spec library to validate these formats. We also provide a JSON schema to go along with it for validation. This allows, for example, if you're in an IDE and you have the YAML, some YAML plugin that pulls schemas from the JSON schema store, that your IDE understands our format, and if you write it in VS Code, for example, that you get sort of a syntax highlighting catered to our format. Yeah, furthermore, the metadata includes hash value comparisons for the files, so that when you then collect files that belong to a resource, you're certain that you have the right ones and you can cache them. And the spec library written in Python provides some of these utility functions alongside the validation process. What can this look like? Just a short code snippet. If you want to describe a model, yeah, you have all sorts of data on your machine because yeah, you just train something, and one of the many ways you can, of course, Anna showed you, have our great GUI to fill us out, and this is just another way here. You can also do this somewhat programmatically in your maybe library that you use to train networks, and then produce these descriptions in Python. What to do with those? Sorry for the noise in the background here. There you go. We have the Bioimaging.io core library that allows users directly to use our resources in Python, as well as many of our tools that build on top of these, for example, Elastic. The library provides model framework adapters, so we have different model formats, model weight formats in the zoo, TensorFlow, PyTorch, and Keras based or Onyx, for example. And for the users of the library, these feel mostly the same. So we provide a common interface to those weights. Yeah, we provide reference implementations for the defined pre and post processings, and the ability to test the model, see if we programmatically can reproduce the test outputs that people have to specify when contributing a model description. It has some additional cool utilities like blockwise processing, so you can process larger than memory files. These capabilities are provided, as I said, as a Python library, but also as the command line interface. And this looks roughly like this. I'll just show you the help message here. So if you install bioimaging.core as the Python package, either with pip or conda, you have this command line interface at your disposal with a variety of subcommands. And all this functionality is also provided in the Python library. An output here from the console from testing a model looks a bit like this. So we have a big emphasis on testing so that we have high quality model descriptions in the model zoo that we share, such that other people can seamlessly deploy them. Yeah, I quickly want to mention what we do sort of in the back office, what we call it, and behind. So we, if you are interested in becoming a community partner, maybe you want to contribute, integrate your tool into our environment, and for this purpose, we have GitHub workflows that test all these models against the different community partner tools. It's quite straightforward to contribute such a workflow so that we can test all the bioimaging resources on your tool, and we can report on the compatibility of a given resource with your tool. And furthermore, sort of some of these CI helps us to keep a high quality collection of models. And maybe, so this looks a bit like this then for maintainers that take a closer look at the zoo. But for users, this is not as relevant. Oh, I'm sorry, this was the wrong button. Just want to go back on this one. And also there you get all these test summaries, and so we can keep a high quality collection of resources for many people to use. And I think with that, I'm already on time, and have to thank you for your attention. Thank you very much. Also, thanks to my lab, the Crashbook lab in the upper right, and AI4Life that we never managed, I think, to have everyone in one picture. I tried to get a big overlap with those two. Thank you.